Okay, so we're going to go over the review for Math 0325. I'll just work through them one problem at a time. I don't know if this will be one video or if I'll decide that it needs to be two. Our first problem says, which of these expressions is not, and we really have to read carefully when we see things, not a way to calculate 75% of 9100. So we need to remember, what is 75%? Well, as a decimal, we can write it as, well, let's even before 75% means 75 out of 100, or 0.75 if we go ahead and write it in decimal form. Or most of us know that 75 out of 100 also reduces to 3/4. So knowing those equivalents are going to make this problem easy. One way you can get 75% is to multiply by 0.75. So this one is correct to multiply by. This one says to divide by 3/4. Well, if we want 3/4 of something, we don't divide. We would multiply. So this correctly calculates 75%. And so does this. That's 9100 times 75. That's that 75 over 100. So the actual answer to the question is B. Another way you could work this would be to take your calculator and work each one of these out. You would see that B gives you a different answer. So B is clearly the incorrect way. Since the table below shows the amount of money Bubba earned each month polishing rocks. Well, that's an interesting job. So we have the data for a 12-month period. They want us to find mean, median, mode, and range. So the first thing we need to do really if we're going to do this is probably to put them in some type of order. If you put them in order, it helps a lot with median and finding that middle. It also helps with the range. So let's go through our numbers. Let's look for the smallest one first. The smallest one that I see is this $15. So we're going to write $15. So what? Let's not write the dollar sign. We know it's money. We'll just write the numbers. So we have 15. So we got that one. The next smallest one is going to be $24.50. Don't see any more in the 20s. Let's go in the 30s. I see 39. And then I see 40. So we've got the first four. 45.50. 48.40. We might have wanted to do this with a stem and leaf. That's another way we could have organized this. 51.80. 3, 4, 5, 6. Okay, the next smallest one I see is 74.30. 75.60. 80. 82.25, 98.45. Okay, let's make sure we have all 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, each one of these we should know how to calculate. Median is middle. The middle in this case is, there are two middle. We need to look at the 6th and the 7th because there'll be 1, 2, 3, 4, 5 below, 1, 2, 3, 4, 5 above. So to get the median, we average 48.40. So we add those two together and 51.80 and divide by 2. We just find that middle point between those two middle values. So our middle value is $50.10. That is our median. The mean, we have to total up all 12 and divide by 12. So we have to sum all of them. So we're going to say 15 plus 24.5 plus 39 plus 40. I don't know why that jumps up there sometimes. Plus 45.50 plus 48.40 plus 51.80 plus 74.30 plus 75.60 plus 80 plus 82.25 plus 98.45. Once I get this sum, and I hope I did not make an error typing anything in, that was 670.80. I need to divide that quantity by 12. That gives me a mean of 55.90. That's what you also think of as being the average value. They also asked me to find a mode, but in this case there is not a mode because each data appears exactly one time. There is not a most frequent. So I would just simply say no mode. And then finally the range. The range is the largest minus the smallest. The largest is 98.45. The smallest was $15. So 98.45 minus 15 gives me a range of $83.45. So there we've done mean, median, mean, no mode, and our range. This next one also is about mean, median, and mode, but this time we've got one of those dot plots. You see all of the x's go from 0 to 10, but some values occur more frequently than others. Our smallest value is right here. The smallest data value is 0. The largest data value is 10. What is the mode? Which data value occurs most frequently? The mode is 6 because 6 happened 1, 2, 3, 4, 5 times. It was the most frequent. And then finally, what is the median? What is the middle value? That might be a little tricky, but if we write it out, I think it will help. There's a value of, let's see how many dots there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I counted 28 dots or X's. Each one of those is a data point. Let's double check those numbers. 1, 2, 3, 4, 5, 8, 12, 15, 20, 24, 26, 27. I still get 28. So I need the middle of 28 is the average of the 14th and the 15th. Because if you think about it, there's 13 below, you want to be in the middle, and there'll be 13 above. So we need to find the 14th and 15th X. So we'll start at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 13, 14, and 15 are all on 5. So our median value is 5. If the 14th and 15th value had been different, we would have been in that position where we had to average the two middle values, but they were both on 5. All right, let's look at this histogram. The histogram below shows the ages of people in Bubba's store when a survey was taken. How many customers are 30 to 39 years old? What percent of the customers are 40 years old or older? So before we can answer this, we are going to need to know how many people are being represented here. So let's just count up everybody. We have 4 people in the 10 to 20-year-old range. We have 7 people in the 20 to 30. And this is really 20 to 29. 30 to 39, we have 8 people. 40 to 49, we have 7. And from 50 to 59, we have 2 people. All right, so we have a total, if we add all that up, if I add 4 plus 7 plus 8 plus 7 plus 2, I have 28 people in the store. All right, how many customers are 30 to 39 years old? 30 to 39, that's going to be 8 people. What percent of the customers are 40 years old or older? Well, 40 or older, that is going to be 9 people out of 28 people. That's going to be a fraction. To make it a percent, we have to multiply it by 100. Because 9 divided by 28 comes out to be like 0.3214. You'll see it on your calculator. But we need that to be a percent. So times 100, that is 32.1%. We'll just do it to the nearest tenth. So that's a histogram. Again, we have another type of graph. This is that box and whiskers. It says the counselor of a local high school wanted to know how many students were enrolled in the math classes offered by the high school. The information is shown in the box plot below. What percent of classes have less than 13 students? Remember, 13, that's right here. This value is the median. So basically it divides it in half. 50%, each one of these, that's 25%, and this is 25%. The box represents 50% of the data, or 50% of the students. In this case, it's the data. It's really class size. Okay, so and then 25% of the classes have fewer than 10, and the last 25% of the classes have more than 14. So these are some pretty small math classes. What percent of the classes have more than 10 students? Well, that should be 75%. What is the range of the data shown in this box plot? Range is the largest, which is 16, minus the smallest, which is 2. So our data range is 14. What is Q1, the median, and Q3? All right, Q1 is 10. The median, we've already said, is 13. And Q3 is 14. Those quartiles, this box breaks things up into a quarter. This is the lowest quarter. This is Q1 right here at 10. And then the next quarter goes from 10 to 13. That's the median. The next quarter goes from 13 to 14. And then the last quarter is 14 to 16. Q3 is at 14. To suppose your monthly wages are divided up based on the pie graph below. If the amount you spend on housing was $875, how much is your total income? Well, your housing allowance is 28%. So your total income would be 28%, and I'm going to use a I for income, is equal to $875. That's your actual housing budget. What does this look like when we solve it? That's 0.28. I don't know why that keeps popping up. 0.28 times I equals 875. If I want to solve for I, divide by 0.28. And I still don't know how to make that stay away. 870. So this left-hand side, those will cancel. I get I. 875 divided by 0.28 is 3125. Nope. Trying to see if I can make that editing stuff stay away. Once we know that, if this is the total income, we could find anything, any part. Like we could say, how much does this person spend on insurance? And we would need to calculate, if we wanted to do his insurance, 9% of the 3125, his monthly earnings. That would be 0.09 times 3125. And we would say, so if we did 0.09 times 3125, we would get that he spent $281.25 on insurance. It said a hospital went to implement a new procedure to minimize the number of patients who developed a hospital-acquired infection. They will either implement a new procedure for patients who get a central line or for patients who are put on ventilators. The table below shows how many patients did or did not get a hospital-acquired infection. Complete the table. So let's start by completing the table. If we go across, this has to add up correctly. 11 plus 30 is 41. So this would be the total number of people who developed a hospital-acquired infection. Okay, the second row is the people who did not. Well, notice there were 45 central line patients. 11 of them got an infection, so 45 minus 11, that means 34 people did not. There were a total of 120 on a ventilator. 30 got an infection. That meant 90 did not. Again, all of these columns add vertically, and they will also work going across. If we want to get the total here, 41 plus 124, we get 165. If we add across, we also get 165. It's very important that that graph work both ways. All right, so we've completed the table. What percent of the central line patients did get an infection? This is very important. That's going to be our base. How many of the central line patients got an infection? How many central line patients were there? There were 45 total. How many got an infection? 11. So the answer to this would be 11 out of 45, and then we multiply by 100 to make it a percent. 11 divided by 45 times 100 would be 24.4%. What percent of patients who did not get a hospital-acquired infection were on a ventilator? Okay, we are wanting a percentage of people who did not get an infection. How many people did not get an infection? I mailed it. There were 124 people who did not get an infection. How many of those were ventilator patients? 120. So 120 out of 165. Again, we have to multiply by, wait, I may not. What percent of patients who did not get an infection? Okay, the number who did not get an infection was 124. How many of those were on a ventilator? That would be 90. So I started to do the wrong column. 90 people out of 124 did not get an infection. So 90 out of 124 times 100%. $72.6. So 72.6%. So most people who were on a ventilator did not get an infection. Of those people who did not get an infection, 72.6% were on a ventilator. Okay, let's see how much more pages I have here. All right, so we have 21 questions. That just gives me an idea of how long I want to keep at this. I'm a little upset I can't get this off your screen here. Okay, I'm going to pause for now, and we'll pick up here in just on the next video. Oh, never mind. Let's see. Okay, let's keep working since I got that to go away finally. says Craig earns $475 per week. He was notified he would get a 2.5% increase in pay. What's his new salary? Again, I want to see if I can make a little room to work some of these. How much does he make right now? He makes $475, but he's going to get a 2.5% raise. So he's going to get 2.5% of $475. This part is the raise. .5% is 0.025 times 475. Now this isn't the only way I could have done this, but let's do it this way first. 0.025 times 475 is $11.88 if we round to the nearest cent. So he's going to get a total of $486.88. That's the correct answer. There is another way we could have done this if we want. We could think of a percent increase like this. He's going to get his original salary or pay plus 0.025 times his pay. Or if you add this together, that's 1.025 times his paycheck. That's a 2.5% increase. The 1 represents his pay. The 0.025 represents his increase. If we do 1.025 times $475, you see we get the same $486.88 we got when we did it kind of separately in two parts. So either way will get us that same result. It's a Honda CRZ can travel 37 miles on 1 gallon of gas. If you drive this car for 1,554 miles and the average gas price is $2.98 a gallon, how much are you going to pay for gas? Okay, we're going to have to think about that. We need to figure out how much gas he has to buy. He can travel, this is really important, 37 miles on 1 gallon of gas. Okay. But he's going to travel 1,554 miles. So 1,554 miles divided by 37 miles per gallon is 42 gallons of gas. That's the first thing you needed to figure out. If he's going to travel 1,554 miles and every 37 miles costs him a gallon of gas, he's going to need 42 gallons. 42 times $2.98, it's a little under $3, is going to be $125.16. I'm going to do one more problem, I think, today. And then we're going to stop this video and save the rest for another video. We'll split this review up into 2 halves. Whoops. It says, while Jesse was traveling on the highway at a speed of 117 feet per second, he sees a deer jump onto the road in front of his vehicle. The coefficient of friction is 0.70 and the roadway grade is 10%. When Jesse applies his brakes, how far will his car travel before stopping? Round to the nearest tenth of a foot. So we need to fill in all of the things that we know. V0 is the initial velocity of the car in feet per second. So we start off, so we know that V0 is 117 feet per second. D is the braking distance. That's what we're trying to find. That's the question. G is the roadway grade. It is a percent written in decimal form. So if our roadway grade is 10% as a decimal, it's going to be 0.10. F is the coefficient of friction between the tires and the roadway, and it is a number normally between 0 and 1. In this case, they say it's 0.7. That is a number between 0 and 1. And there's a comment that good tires on good pavement provide a coefficient of friction of about 0.8 to 0.85. So these are not perfect. And G is acceleration due to gravity, and it's 32.2. So they've given me everything I need. I just have to carefully plug it in this formula. D, whoops. Let's try that again. D equals V0 squared. So 117 feet per second squared over 2 times G. G is 32.2. And then in parentheses, they show lowercase f plus capital G. That's our formula. We can work it out kind of step by step. 117 squared is 13,689 over, and then if we multiply this bottom, this is going to be 2 times 32.2. We need to add first. 0.7 plus 0.1 is going to be 0.8. That was 0.70. So we're going to have 13,689. 2 times 32.2 times 0.8 is 51.52. So now we just have to divide. And I get that the stopping distance is 265.7 feet. I just have to be really careful filling that in. All right, this looks like a great place to stop. We'll do the other half in a separate video.